Okay, so today we're going to talk about line equations and everything that kind of goes with line equations. Here's the general form for a line equation. It generally comes in this form, which is y equals mx plus b. And here's what these symbols mean. M stands for your slope. And B stands for your y-intercept. Okay? And let's talk about what those things mean. Well, you should know slope from yesterday, which is rise over run. So we're going to plug in, this is the rise over run. Most times it is in some kind of fraction. So most times, when I write this, I want you to think about the m term being some kind of fraction, being some kind of rise over run thing. And then we have the y-intercept. And the y-intercept is on a graph where it intercepts the y-axis. So if I had a line, the y-intercept for me would be right here, or where the y crosses, or where the line crosses the y-axis. So that's my y-intercept in this case. And again, it kind of makes sense because y-axis, intercept, meaning crossing. So there's my y-intercept. We're going to look at a couple lines and see if we can write some line equations from them. Now let's say they give me that m is 4 and b is 3, and they want me to write a line equation. Here's what I would write for this example. I would write that y is equal to 4 over 1 x plus b, or plus 3. You might wonder, well, why did you make this 4 over 1? That just says 4 right here. And if you think back to before, I really want this to be a slope, and a slope is rise over run. And if they give me the number 4, if it's not a fraction, I would like to put it into a fraction. So if you think about it, 4 over 1 is the same thing as 4, because 4 divided by 1 is just 4. So if they give me my slope and it's not a fraction, I will put it into a fraction. Let's see a second example. Okay, so let's say they give me this, and they want me to write a line equation. I'm going to write that y is equal to negative 3 over 5x plus 5. Because again, my slope will go in front of my x, and my y-intercept will go behind my x. So that's, again, this is kind of the way that we write these line equations. Let's see a case where instead we are going to actually write the slope and the y-intercept given a line equation. So let's say I was given this line equation. And they wanted me to write the slope, and they wanted me to write the y-intercept. My y-intercept for this problem would be this number out here, which would be 5. My slope for this problem would be that number right here. Now what I would write for my slope would be negative 2 over 3. And you might go, well, why did you put the negative number that was on the bottom, and why did you move it to the top? The reason I did that is I don't like when my negatives are on the bottom, because in fractions, this is my part, and this is my whole. So I don't like when my whole is negative. So if you ever have a negative on the bottom, just move it up to the top. Let's try these from some graphs, and then that will be my last example. Okay, let's say they've given me a graph. Now for this first graph, I know that I want this to be in form y equals mx plus b. And I can see that this should be my slope, and this is going to be my y-intercept. My y-intercept is where this line over here, this line that's over here, crosses the y-axis. So when I look, it looks like it crosses the y-axis right here. So this would be my y-intercept, which would be at 0. Now I'm going to try to find my slope. So that's one of my points. This would be another point, and if you remember from slope, it's rise over run, so my rise would be 1, 2, 3. My run would be 1. So this equation would be 3 over 1x plus 0. Let's look at a second example. So we're going to move this over. We're going to change colors. Okay. So if you look at this, again, I'm going to do y equals mx plus b. And for this one, my y-intercept would be right here. So that would be at 1. My slope, there's 1 point. I think here would be my next point. So we're going to count how much down and over. I would go down 1, 2, 3. So that'd be negative 3 over. I'd go over 1, 2, 3, 4, 5. Let's do one more example. This is a good one. Okay. For this one right here, again, we're going to do the same thing. I would need to do y equals mx plus b. I can see that my y-intercept this time is 4. Now I have to find my slope. Here's my nice part. My slope is just over 1. So it's up 0 and over 1. Another way I could write this one is that 0x would just be nothing. So this could also be written as y equals 4. So that's the other way you might see it. But that's kind of the basic ideas of how we would write these line equations. I have one more example for how you would write this from a word problem. So let's see that. Okay, so let's see it from a word problem. And as you can see, like in this, it says you are visiting Baltimore, MD, and a taxi company charges a flat fee of $3. And using the taxi company, like it charges 0.75 cents per mile. So then they want me to write an equation and then figure some things out. So like in this example, if I'm going to write an equation, I know that I'm going to have y equals mx plus b. And because it's asking for a linear equation. Now here's what I want you to think about. There's a couple different words that we're going to just call these different words moving forward. M in a word problem isn't going to be called the slope. It's going to be called the rate of change. And it's going to tell you what thing is changing. Like in the problem, what thing is changing. And your y-intercept, we're not going to call this a y-intercept anymore. We're going to call this our starting point, or your entry fee, or like what do you start with? So this is kind of the idea behind this, is this now becomes my rate of change, and this becomes my starting point. So in this problem, or it's just for me to write this, I'm going to read that, and I'm going to go, okay, what does that 3 represent for me? Well, that 3 kind of represents my starting point. It's my flat fee that they just charge me right off the bat. So that's going to go in for my y-intercept. And then when I look at this 0.75 per mile, well, that's really my rate of change, or how much things are changing. Okay, so that's the kind of the basic idea behind this. Is like this is the starting value, and this is how much things are changing. Let's look at another kind of problem with this. Okay. So when I read through this one, it says a plumber charges $50 to make a house call, and then $25 per hour of every labor. So again, I'm going to say y equals, and if I look at this again is the starting amount. Just to come out, he's going to make me pay 50 bucks. So that's my starting amount. And then for every hour, so the part that changes, this could be 25 or 50 or 75 or 100, depending on how many hours that he's going to be there. So that's kind of my rate of change. So that'd be my equation right there. Let's look at one more example. Okay. So in this last one, it says write an equation to model this situation. So for this one, again, I'm going to start off the same way. We got to look for our starting point, and it says an airplane starts 30,000 feet above the ground and then starts descending at a rate of 2,000 feet per minute. Well, that makes it easy because they start at 30,000 feet above the ground. So that'd be 30,000. And then my rate of change would be 2,000. Now, I don't want to just put 2,000 because what direction are they going? They're descending. So what would descending mean to me? Oh, I'm not going to go a positive. I'm going to go negative 2,000 above. So let me write that a little bit better because I didn't give myself enough room. But my rate of change would be negative 2,000x plus a 30,000. Okay. That's kind of how I model these problems. It's just like that. Okay. So try these problems. If you have any questions, again, I'm going to be online from 2 to 3, answering any problems or questions that you have. And then feel free to send me an email at any time. Thanks.